All right, let's take a look at ionic bonding. So there's three major ways that atoms bond together. The first method is metallic bonding, which is how metals bond. Second one is covalent bonding. And the third one is ionic bonding. Now in this video, we're going to take a look at ionic bonding. So ionic bonding is between a metal and a non-metal. So more specifically, it's the transfer of electrons. So valence electrons. So valence just basically means electrons in the outermost shell. So ionic bonding is the transfer of valence electrons from a metal to a non-metal, forming ions. So an ion is basically just a charged atom. It could either be a positive charge or a negative charge, depending on whether it loses electrons or gains electrons. Let's take a look at what ionic bonding, why it happens from a metal to a non-metal first. If you look at metals on the periodic table, they're going to be on the left side of the periodic table. So they're either going to be in groups 1 or 2, or they're going to be transition metals. But transition metals don't do ionic bonding. It's either going to be group 1 or group 2. So if we take a group 1 metal, for example, we could take sodium. Sodium has a mass number of 23 and a atomic number of 11. You don't need to memorize this, by the way. It tells you on the periodic table. You do need to know that the top number is the mass number and the smaller number is the atomic number, though. Let's take a look at chlorine. Chlorine is a non-metal. And chlorine has a mass number of 35.5 and an atomic number of 17. So sodium is in group 1. It's also called the alkali metal. And chlorine is in group 7. And group 7 is called the halogens. So this is a metal, and this is a non-metal. Remember, everything group 1 and group 2 is all non-metal, all metals, and everything on the right side of the table, including group 7, is going to be non-metals. So chlorine is a non-metal, and sodium is a metal. Now, what do these group names tell us? I covered this in the previous video going through the periodic table, but the group names tell us the number of valence electrons, so the number of electrons in the outermost shell. So if you draw a dot and cross diagram for sodium, sodium is going to have one valence electron because it's in group 1, and you can also find it scientifically. It has 11 electrons in total, right? So first shell can hold a maximum of 2, and the second shell onwards can hold a maximum of 8. So 8 plus 2 is 10, so the third shell is going to have to hold 11 minus 10, which is 1. Chlorine is in group 7, so it's going to have 7 electrons in its outermost shell. I'll differentiate the electrons by making this one circles. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Chlorine has 7 electrons. We can also find this out. First shell will hold 2, right? Second shell will hold 8, so 8 plus 2 is 10. And the third shell will hold 17 minus 10, which is 7. So 7 in its outermost shell for chlorine, and 1 in its outermost shell for sodium. Now, think about it. Atoms want to have a full outer shell of electrons, right? Now, this is in its third shell, and this is in its third shell too. So both of these shells can hold a maximum of 8 shells, 8 electrons. Now, sodium has 1 electron in its outermost shell, and chlorine has 7 electrons in its outermost shell. So these both want a full outer shell of electrons. So for sodium to have a full outer shell, it can either get rid of this 1 electron, or it can receive 7 new electrons. For this chlorine to have a full outer shell, it can either get rid of these 7 valence electrons, or it can receive 1 electron. What's easier? It's way easier for sodium to just get rid of 1 and for chlorine to just receive 1 than to getting rid of the 7 and receiving 7, right? These atoms are lazy like us. It wants to take the shortest and easiest path possible that requires the least amount of energy. So what can happen is these guys can form symbiotic relationships. So if you know nature, you'll know what symbiotic means. Symbiotic is basically when it's like a mutual benefit. So there's these fishes that clean sharks' teeth, and it gets rid of the waste on sharks' teeth, so these fish can get some energy from eating the shark's waste on its teeth, and the shark gets a free dentist appointment. That's a symbiotic relationship. This is also another symbiotic relationship, a mutual benefit. This sodium can give 1 electron so that this can have a full outer shell because it'll have no electrons here, so it'll go down to the second shell. And this chlorine can also form a symbiotic relationship because it receives 1 electron, so this can also have a full outer shell of electrons. Now we can represent the electrons of sodium and chlorine by using something called equations. You do need to know how to write equations for these bonds. For sodium, sodium is going to be Na, right? And this sodium is going to be losing an electron. So if it loses one negative electron, it's going to form a positive charge, right? Because there's going to be more positive protons than negative electrons. There's going to be one fewer negative electrons, so there's going to be one more positive proton, leading to a 1 plus charge. So the sodium goes to form sodium plus, Na plus, and it's getting rid of one electron, right? So Na plus and one electron, which is negatively charged. So Na plus and E minus. This minus shows us that the electron is negatively charged. This chlorine, well, the chlorine is receiving one electron, right? So this chlorine receives an electron. So this electron is coming over here. And this goes to form Cl minus. Because this chlorine is now going to be negatively charged. And this sodium, well, this is losing an electron, so it becomes sodium plus, a positively charged sodium atom with one electron. This chlorine receives an electron, and it becomes Cl minus. It's really important to write this in this order. You can't write Cl minus is equal to Cl plus E minus. You have to write it in this very specific order. And we can now draw what this ionic bond looks like by using something called dot and cross diagrams. These are dot and cross diagrams. So the sodium atom is going to give one electron to chlorine so that they can have both full outer shells, right? So, Na. This time I'm going to draw the entire atom, not just the outermost shell. So Na has 11 electrons in total. So it's going to be 1, 2 in its first shell, 8 in its second shell. So it currently has 10 electrons. And it's going to have one more electron in its outermost shell. But I'm not going to draw it. You'll see what happens in a second. Now I'm going to draw chlorine. Chlorine has 2 electrons in its first shell. Now remember to differentiate it. Draw chlorine with circles and sodium with crosses, or vice versa. You want to know the movement of electrons. Second shell will hold 8 too. So chlorine currently has 10 electrons, but it has 17 electrons in total. So we need to draw 7 more. 3, 4, 5, 6, and 7. So it currently has 7 plus 8 plus 2. So 17 electrons, and sodium has 11 electrons. But I didn't draw the last electron here on purpose, because these are going to go to form ionic bonds with each other. Now what these brackets show us is that it tells us that these are ionic bonds. Now notice how I didn't draw an electron here? I didn't draw it on purpose, because this one electron is going to move here, and we draw that with a cross because it's an electron from sodium going to chlorine. Now this sodium just lost an electron, right? So Na went to form Na plus, a positively charged sodium atom, because it lost one negative electron, plus a negative electron. This negative electron went to chlorine, plus one negative electron went to form chlorine minus. And this arrow shows the movement of electrons. So the chlorine's outermost valence electron went to chlorine. So sodium's outermost valence electron went to chlorine, so that these could both have full outer shell of electrons. Now this is the movement of electrons. And these are now attracted to each other, and so they are now called an ionic compound. Remember, a compound is when you have 2 or more different atoms. A molecule is 2 or more of the same atom, so this is a compound because it's 2 or more different atoms. It's an ionic compound because this is oppositely charged, right? Sodium is now positively charged because it lost an electron, and chlorine is negatively charged because it received one electron. So opposite charges, it's kind of like magnets, how oppositely charged magnets are attracted to each other, right? The north and south face is attracted. So they are now attracted to each other through ionic bonds. So sodium and chlorine are now ionically bonded together, so they're chemically bonded, and they are now forming an ionic compound. So the bond between sodium and chlorine is called ionic bonds, and it is called, the overall entire thing is called an ionic compound. Now, why are they attracted to each other? They're attracted to each other by electrostatic forces. Kind of a tough word, right? Electrostatic forces. attracted by electrostatic forces. So these sodium and chlorine atoms are attracted to each other by electrostatic forces, which is basically opposite charges. It's basically just magnets. It's kind of like magnets attracting to each other in north and south face, right? So they're attracted to each other by electrostatic forces because they're oppositely charged, and which forms an ionic compound. Let's take a look at one more example, just so that we can fully consolidate the idea and what actually happens. So we're going to draw the dot and cross. In your exams, it's going to ask you like this. Draw the dot and cross diagrams for the formation of magnesium chloride. And I'll tell you that it's MgCl2, magnesium chloride. And only draw the outermost shell. So in the previous example, we drew all the shells. But this time we only have to draw the outermost shell, so it's going to save us some time. So we need to draw the dot and cross diagram for the formation of magnesium chloride, MgCl2. So, in this example, we have 3 atoms. Previously, we only had 2 atoms. Now we have magnesium and chloride. We have one magnesium and 2 chloride atoms, chlorine. Chlorine and chloride is the same thing. Chloride is just the bonded form. So if we look at the periodic table, you're going to look for magnesium first. And magnesium has a mass number of 24 and an atomic number of 12. If you look at chlorine, chlorine has a mass number of 35.5 and an atomic number of 17. Now, remember, the atomic number tells us the number of electrons. Since the question only asks for the outermost shell, we only need to draw the outermost shells, right? So first of all, let's draw the outermost shell from magnesium, what it would look like. The first shell is going to hold 2. The second shell is going to hold 8. So 2 plus 8 is 10. So the last shell is going to have 2 electrons. And now we have 2 chlorine atoms. First shell holds 2. Second shell holds 8. So 8 plus 2 is 10. And we have 7 valence electrons. Oh, yeah, I should draw this with circles, right? So we can differentiate. 7 electrons. And another chlorine atom with 7 electrons. So this is only the outermost shell that we've currently drawn. Now what's going to happen to magnesium? The magnesium is going to lose an electron, right? It's not only going to lose 1 electron, it's going to lose 2 electrons. So this magnesium is going to go to form magnesium 2+. It's going to gain a 2+ charge because it's going to lose 2 negative electrons, right? So when you lose 2 negative electrons, there's going to be 2 more positive protons. So it's going to have a 2+ charge. So magnesium 2+ plus 2 E minuses. So it's going to have 2 electrons that are going away. Because magnesium forms a 2+ charge, right? Because 2 negative electrons are gone. And it also forms a 2 E minus charge because there's going to be 2 additional electrons. Let's take a look at chlorine then. What's going to happen to chlorine? Chlorine plus chlorine's going to receive an electron, right? So chlorine plus E minus 1 electron is going to form chlorine minus a negatively charged chlorine atom. But we're going to have 2 of these. Now, why do we have 2? Because we have 2 chlorine atoms. For magnesium, we drew it all in one equation because magnesium 2+, it's only 1 magnesium losing 2 electrons. So you can express it in one way. And you might think you can just express it in one way because chlorine receives the 2 electrons, right? But it's 2 different chlorine atoms. So you have to write it twice. Chlorine plus electron makes chlorine minus, and another one. Chlorine plus electron makes chlorine minus. Now let's look at what this would look like in a dot and cross diagram. So what do you think is going to happen? Chlorine has 7 electrons, magnesium has 2. Magnesium wants to get rid of these 2, chlorine wants to receive 1 electron each. So magnesium can give 1 electron to each of the chlorines. So we can see magnesium. Now this time we're going to draw magnesium in the center because they're going to bond like this. they're both going to be attracted to magnesium because magnesium has the 2 electrons, right? So magnesium is going to give 1 electron to chlorine and 1 to chlorine. So they're going to be bonded like this. So it wouldn't be chlorine, magnesium, chlorine, chlorine like I drew in this order. We're going to have magnesium in the center, right? So magnesium is going to have an empty shell because it's going to get rid of these 2 electrons, right? So it's going to become a 2+ charge because it gets rid of 2 negative electrons. And now we have chlorine. And chlorine is going to have 7 electrons already. But it receives 1 of the electrons from magnesium. So it's going to have a negative charge because it receives 1 negative electron. And the same thing is going to happen here. Chlorine currently has 7 electrons, but it's going to receive another electron from the magnesium, going to form a negatively charged ion because it receives 1 electron, negative electron. That is pretty much ionic bonding. And that's pretty much all you have to do. And now these are bonded. There's going to be ionic bonds between these atoms. Magnesium is bonded to both the chlorines. So these are ionic bonds. And they go to form an ionic compound, because it's different atoms bonding together, right? So it's an ionic compound, 2 or more different atoms. That's pretty much all you have to know about ionic bonding. In the coming videos, I'll look at ionic compounds in more detail because they have special properties. And also I'll look at the differences between ionic bonding and covalent bonding, which is also a different type of bonding, but covalent bonding only occurs between nonmetals. Now, why is ionic bonding between metals and nonmetals? Because metals want to get rid of their electrons and nonmetals want to receive electrons. Because metals are in groups 1 and 2, so that it's easier for them to get rid of electrons, and nonmetals are in groups 5, 6, and 7, so they want to receive electrons because this is the least energy intensive process, and atoms are lazy just like us. That's pretty much all you have to know about ionic bonding and ionic, and these form ionic compounds. And also look at the properties of these in coming videos.